All right, let's talk about exam number 3. Feels like we just took exam number 2, doesn't it? They come so fast and furious here at the end. And of course, it'll seem like the final exam is the day after. It'll seem that way. They come so rapidly. But exam number 3 is over 2 sections of Unit 3. It's over section 1, the sun, and section 2, the moon. Section 3 on the planets is being left for after exam number 3, and you'll only see that material on the final exam. So in preparation, getting ready for exam number 3, you want to do really 2.5 homeworks. We do homework 6 and 7. 6 is entirely on the sun. 7 is half on the sun and half on the moon. And then the first 2 questions of homework number 8, which is half of homework number 8, which is on the topic of eclipses and tides, so that finishes up the moon. So, if you've been staying on top of it with me, then you're already up to date. Otherwise, you got lots to do. But they're very helpful for leading you down the path of understanding, okay, for both sun and moon. The self-test, which of course is made available to you on the Canvas page, but if anybody downloaded the entire workbook, it's found on page 118 of the current version. And the self-test for Unit 3 is bigger than just sun and moon. It includes the planets. So let me direct you. The sun and moon questions are questions 1 through 32. So you can draw a line right after question 32 and say, leave that till later. Yes, for after exam number 3 is over. And there are 8 essay sample questions at the end of the self-test. Yeah, it's kind of nice of me to give you that many, wasn't it? And it's the first 6 that are sun and moon. The last 2 are on planets. So leave those again till later. And the answers are posted up on the web page, the Canvas page, but they're also in the back of your downloaded workbook if you did do that, and that's back on page 171, okay? If you're having issues finding either one of those 2, please just shoot me an email. I'd be happy to direct you where on the Canvas page to find these 2 things, all right? So, all right, we're clear, and I'll say it one more time. This exam number 3 is only over sun and moon. No planetary questions this time around. And the format for the exam is going to be very similar to exam number 2. I'm going to give you 3 parts. And part 1 is a freebie, meaning you can do it as many times as you want. Yes, there's a limited amount of chances to take this quiz. And it's primarily to get you in the swing, in a zone of comfortability with making an image, uploading it to the Canvas quiz, which we've now been doing, for the last 2 exams, and last 2 quizzes, I guess, over exam 2, and giving you some experience and hopefully relaxed experience with doing this. You can have as many chances as you want, and it'll get you 2 points if you do it correctly and upload the image. Then come exam day, which is on Tuesday. We'll actually have you do it one more time. This time it counts, and you'll be given 30 minutes to do it, and you have no expectation as to what the actual problem is. So this one, is free, and I'm sure you'll get your 2 points and get those 2 points. And in this one, if everything goes well, it's worth 10 points, and I'm sure it will with all the experience you'll have doing part 1. Part 3 is also scheduled for Tuesday. I don't mind if you do part 2 before part 3 or vice versa. But part 3 is a timed and proctored exam. It's going to be using Proctorio again. And it's where you primarily do, of course, a lot of typing. There will be both fill in the blanks. If I were to guess, I'd say about 12. And the fill in the blanks are primarily over motion questions. And there'll be some phase questions too. And essays, paragraph style answer, or 2. 2 paragraphs is good too. So with sun and moon, you expect about 4 or 5 questions for each of those 2 major topics, sun and moon. And that'll, of course, require you to really think your way through it and to really explain yourself, hopefully in an elaborative manner. But back to the fill in the blanks, I'll draw you some lunar phases, some shaded circles, and ask you what phase they are. I'll ask you to tell me where the sun and moon are in a matter of hours, or in a matter of days, or in a matter of weeks. So they're daily and annual motion questions. And there's plenty of those types of questions in the self-test. So it's really good practice to do all those first before you take the real exam on Tuesday. Okay? So there's the preparation. Here's the format. And let's do a little bit of review. Our workbook is set up such that When you get to a major section, part 1, the sun, letter A, letter B, letter C, these are the major subsections, and they are the review items that I'll write down for you again here. But, it's good to emphasize and to really give you a clue as to what's important as I talk about each one. So either freeze me or pause me, and I'm going to erase this, and we'll talk about the review of the 2 major sections. Okay? All right, let's see how well this erases today. Yeah, it's a chilly day in here in the classroom, and whiteboards are much harder to erase when it's chilly, so that's why it's looking like it is. Clearly the blue erases much easier than the black as well. All right. Let's start off with part 1, the sun. And in units 2 and 3, we've gotten to a major section, a major topic, stars, sun, moon, and how do we lead them all off? Talking about daily and then their annual motions. So if I put a letter up here, for daily, what's the Latin word for daily motion again? Yeah, diurnal motion. Synonymous, same thing. And then we learned about the sun's annual motion, or I guess that's the Latin variety. What would be the English variety of annual motion? Yeah, we just say yearly. But please know both yearly and annual motion are the same thing. And to assist us with learning about the sun's yearly motion, we of course did assignment 2. We have plotted 12 suns across 2 sky charts. And that was the basis for us determining the sun's daily rate of motion across the stars. And it was also the basis for us figuring out things like where are the equinoxes and solstices going to be due to precession in the future. So it was a very helpful diagram, and you just might see a bit of that on the real test. So be familiar with it, assignment 2. Okay. Again, these 2 topics really lend themselves to the fill-in-the-blank questions. Where is the sun going to be in 3 hours? Well, daily motion is described with an hourly rate, isn't it? 15 degrees per hour, east to west, with respect to the horizon. Good. So in 3 hours' time, 45 degrees further to the west with respect to the horizon. Versus yearly motion, the motion that occurs within a year, but observed at exact 1-day intervals. So it's described with a daily rate, isn't it? Where's the sun going to be 3 days later? Well, on a daily basis, it moves just 1 degree per day with respect to the background stars. So 3 days, 3 degrees, west to east, right? Opposite direction now for annual motion. And that's again with respect to the background stars. So it's even with respect to a new thing. So where's your best friend for kind of categorizing and memorizing daily and annual motion? It was that table of motion that we made together in unit 3 here, page 83. And if you've filled it out with me as we lectured through it, great. Really spend some time memorizing that table of motion. Then after we talked about daily and yearly motion of the sun, then we talked about the ecliptic, didn't we? And the ecliptic is a fancy word, really comes from the phrase, the path upon which eclipses occur, but it's just the sun's path across the sky, isn't it? And that was so helpful for us determining what else? What are the 4 major points on that path? Yeah, equinoxes and solstices. And at one page in the workbook, which defines all these terms, is just, target rich in terms of exam purposes. That's the solstices. And, it's a really a good thing to review and to be very, very on top of. Ecliptic, equinoxes, and solstices. Then after that, we talked about the solar year, which is really the time interval for what? For the sun to make it all the way around the ecliptic once. Yes, with respect to what? Background stars. So, knowing the fact that 365 1/4 days is an approximation, it's pretty close to the real thing. but realizing that it's ever so slightly shorter than that, and hence the reason why we have these things called, well, leap years due to the extra quarter of a day, but that we refine it even further, don't we? Yeah, the Gregorian calendar takes care of the fact that it's not a perfect extra quarter of a day each and every year. So there's lots going along for the ride when you talk about the solar year. We also talked about time and calendar. So all things of time and, well, date are really due to our, predominant object in the sky, the sun, aren't they? So there was plenty of text, plenty of written pages in the unit that talked about time and timekeeping and calendar. Please read them if you haven't already. And I'll ask you a question about those three topics just to make sure that you're, on top of things and keep you honest. Okay. After that, we talked about, now that we know where equinoxes and solstices are and our placement in the orbit, we could do our own estimation of sidereal time, couldn't we? And how is that going to show up? That's right, E is for the part, but how is that going to show up on the test? Well, that's where parts 1 and 2 come into play, right? Where you're actually drawing the diagram for estimating sidereal time. So clearly, it's a big deal, and it's something you want to master prior, of course, to, that Tuesday of the exam. So there's lots and lots of review and lots of examples that were done in the lecture tutorials. And generally when you draw, these things go great, much like they did on exam number 2. Okay. And then how did we end up with the sun? We talked about the zodiac, fancy word for a subset of the constellations which all straddle or, have a leg on either side of the ecliptic. And of course, there are the 12 famous astrological zodiac constellations, but the 13th is Ophiuchus, right, that all straddle the ecliptic. And then in the end, we talked about precession, didn't we? So, precession. It was a major topic with plenty of little lecture tutorials on it. And we should know both the cause and the effects. And boy, do they make great essay questions. Yes, the cause and the effects of precession. How many effects of precession were there? Do you remember? I know, you'll know by Tuesday. But there were 3 major effects, weren't there? Okay. You talk about the cause of precession. The cause of precession is not the wobbling of the earth. That's what precession is. You say precession is the wobbling of the earth. Is caused by what? Yeah, the fact that Earth is spinning on a tilted axis and both the moon and sun are trying to upright torque the Earth upward due to gravitational pull. So yeah, use all those nice fancy words when you talk about the cause and again, the effects. It's on a nice little slide in the PowerPoint lecture talking about the NCP tracing out a circle in the sky, the equinoxes and solstices drifting westward along the ecliptic. What was the third one? Yeah. If you move the vernal equinox, then all the angles you measure from the vernal equinox are also changing. And what angle do you measure from the vernal equinox? Going back to unit 2. Right ascension. Yeah, the right ascension of all the distant stars are going to increase as well due to this. So now already is a lot of stuff, and that's just half the exam over the sun, right? Yeah. Okay. So again, these are just letters in the unit, and I'm sure that you could find them very easily if you wanted to, but hopefully just talking you through it a little bit helps to emphasize what is important. Okay. All right, on to part 2, the moon. Well, the moon is the next major object, if you will, in our discussion of the visible universe. So, of course, we begin the same way with A and B. Daily, and we're going to call it monthly as opposed to yearly motion for the moon. But we'll say this is part 2. The moon. And its daily motion is incredibly similar to the stars and the sun's daily motion. That's going to be hard to wrap your head around, but the daily motions are all extremely similar. They're all the same direction, east to west with respect to the horizon, and they're all right around 15 degrees per hour, aren't they? But the moon is the most significantly different at 14.5, and we'll need to know why. Because as the Earth is spinning at 15 per hour, what is the moon doing? It's orbiting the Earth by about 1/2 degree per hour. That's what causes the 1/2 degree difference per hour. Let's replace that word yearly with monthly. Although when you're writing down a table of motion, we just call this long-term motion the annual motion, right, of all the objects. So understand that they're synonymous when you're talking about the moon. So we did an assignment 3, plotting all those moons, 32 of them. And if you did that, kudos to you. And we learned in the end, when you superimposed it on top of the ecliptic, that they weren't exactly the same, were they? Yeah, that told us that the moon's orbit was slightly different than the Earth's orbit about the sun, otherwise known as the ecliptic. So we learned the fact that the moon's orbit is tilted or inclined, didn't we? And we had some discussion questions about the moon's orbit and why that is. More than likely, yeah, the moon crashed into the Earth billions of years ago to actually cause our companion to be in a stable orbit around us, thereby really demolishing both worlds in the process, but they all reformed, didn't they, into their fairly spherical objects that they are today. And what came along to the right with the moon's orbit? What do you call the crossing points of the moon's orbit and the ecliptic? Nodes, right? Yeah, those are introduction to nodes. So I can put it up there for you, sure. And nodes. And then we talked about lunar rising and setting and transit times. Now, this is not dealing with phases yet, but just in general, lunar rising and setting and transit times. Sure, I'll write them all. And what do we learn about the moon? Does it rise, transit, and set earlier or later every day? It's later, isn't it? Yeah, which is a little bit different than the stars, which do everything earlier every day by 4 minutes. The sun, being our celestial timekeeper, tries to do everything at the same time every day. It's midday when the sun's in transit every day. And then the moon does everything later on a daily basis. About how much later? 48 minutes later. Good. So if the moon rises tonight at 9 p.m., what time does it rise tomorrow night? Later? 9:48 p.m. Yes, got to add. And then we talked about, of course, phases, and that was a big topic. And we learned their identities or their definitions or their appearances first, and we drew them, didn't we? So on the test, expect me to draw you some phases, let's say 4, and ask you to identify them. If I draw you this one, there's the circular moon, and I'm going to give it a sliver or a crescent on the right, and I shade in the right side like this. And again, we're trying to concentrate on the illuminated side. The shadowed side is what disappears into the darkness of night. Yes, so what we see is the left-hand side lit, majority lit, which makes it a what? Majority lit is a gibbous moon. And the fact that it's lit from the left-hand side as opposed to the right, looking more like a C than a D, remember Doc? Yeah, this is a waning gibbous. Good. So know their names for sure. And then the lunar dance, right? Spinning with ourselves representing the Earth, our left arms being the east. Yes, our right hands being the what? Yeah, the west. And it's okay to just put them on your palm like that and spin yourself to try to figure out rising positions on the eastern side, setting positions on the western side as you spin in the room. Yeah, it's okay. I expect you to see you standing up and spinning, yes, as you're doing these questions on the test. So phases of the lunar dance. Then we learned about the 2 major periods of the moon. You have your sidereal. What does the Latin word sidereal mean again? Stars. So this is the moon's star period. The length of time to get back to the same star again, which was the shorter of the 2 periods. That's the 27.3 Earth day period. And then you learned about the synodic period. Latin, sonatus. If you say it fast enough, sonatus even sounds like sun. And that's the sun period, the length of time to get back to the same phase again. So how long was that for the moon? If you said a month, I say, boy, that's fantastic. That'll work every time. But, you know, it's about 29 and a half Earth days long, isn't it? So these days, the months are slightly longer than 29 and 30 days, and that's because you need to have 12 of them fit nicely into a solar year, and they had to be lengthened for that reason. So the sidereal and synodic periods of the moon. And why are they different? What's the root of the cause? Because as the moon is orbiting the Earth, what is Earth simultaneously doing? It's orbiting the sun. We take ourselves out of alignment with these two other objects, and thereby cause the moon to take longer to return to the same angle with the sun, as seen from our perspective. Okay. And then, if that weren't enough, right, you finally make it to homework number 8 material, and we talk about eclipses, and we talk about the 2 major types. When I say the 2 major types, what am I talking about? Lunar eclipses, where you cover Luna, the moon, and solar eclipses, where you cover the sun. And we need to know the phases necessary for that. We need to know about umbra and penumbral shadows. And we need to know about any other conditions that are necessary for these 2 different types of eclipses to occur. In the moon's case, it's much easier to cover because the Earth's shadow in space, the umbral shadow of the Earth, is much larger than the moon. But in the solar eclipse case, it's a much rarer event, isn't it? Because, boy, everything's got to be just right. The moon's got to be what phase again? New moon to cover the sun. And then the moon has to be at a node, so it's at the correct vertical alignment, getting in front of the sun. And then what's the third condition again? Yeah, due to the fact that the moon's orbit is not perfectly circular, it also needs to be near enough to the Earth so that its angular size is big enough to actually cover up the sun. Yeah, so there's more going on with the solar eclipse. And then you learned all about tides, which is an interesting topic for the Bay Area. Not as interesting if you live in Kansas, but it's pretty interesting for us that are so close to the ocean. And I'm sure it has a detail that can be used for the rest of your life if you know about basically the geometry of the different tides. Tying the two together, right? Part 1, the sun, and part 2, the moon. We know now that tides are affected primarily by the moon. That's why it's in the moon's section. But they're operated or manipulated secondarily by the sun. And it's all about alignment, isn't it? When the moon and sun are cooperating, when they're pulling along a common line, either in the same direction, new moon, or in opposite directions, full moon, that causes the strongest tides of them all. What are they called? Spring tides, good. And when the moon and sun are at right angles to each other, then the poles are, well, destructive, aren't they? They're not pulling in the same direction, so we call these neap tides. So knowing the geometries necessary for the 2 types, neap and spring, is a great essay question. And I'm almost out of room here, but if there was a part I, and there's going to be, the very last thing we squeezed into the section on the moon was for non-uniform motion, right? I know it barely fits, but that's an I, and that says non-uniform motion. What is the best synonym for uniform again? Constant. So non-uniform is non-constant motion of the moon. And now that we all believe in gravity, at least I think you do, and we understand what causes these dynamics, celestial speaking, now it makes sense, doesn't it? When the moon is near to the Earth Earth's gravitational tug on the moon is even greater, and it causes the moon to orbit us even faster. So this non-constant speed of orbit is due to the non-perfect orbit of the moon around the Earth. And what a great lead-in that was for talking about planets coming up next. Okay. So, of course, this is just the major topics that are in your workbook. So I'm not telling you anything you don't know already, but hopefully the emphasis was there and you realize that, okay, I think I have a better handle on what's important at this point. So 3 parts to exam number 3, but of course the big part, the proctored part is, it's going to take most of your time and effort in terms of studying and taking the exam itself. Okay? The sidereal time problem is going to go great. I'm sure of it. Both part 1 and part 2. All right? Okay. If you have any questions, of course, email away and set up a Zoom if you need to. And best of luck.